Now we are in the continuation of the chapter, combination word problem. We will see some few more questions. The next question we have is question number 8. This question says, in how many ways can a student choose 5 courses out of 9 courses if 2 courses are compulsory? Right? Total there are 9 courses and you have to select 5. Total there are 9 courses and you have to select 5. But the condition is, out of those 9 subjects, 2 subjects are compulsory. Total you are supposed to take 5 subjects. Out of 9 subjects you can select any 5 subjects. But the condition is, the 2 subjects are compulsory. Whether you like it or not, you have to take. In our case, we can say English and Zonka. Compulsory. Then other than these 2 subjects, you have to choose. Total you need to have 5. Out of 9 subjects, 2 subjects are compulsory. That means the number of subjects will reduce now. Now you have how many choices? Now you have total 7 subjects. Choices. What is choice? The number of subjects available for you to choose is called as choice. Am I clear? So now you have only 7 subjects available for you, and out of these 7 subjects you have to select any 3. So in how many different ways you can do that? The solution is very simple. Now we can find out the number of choices. Question number 8, right?
Yes, sir.
So number of choices or number of ways you select the subject, right? This will become 7C3. Is it understood?
Yes, sir.
Is this part very clear or not?
Yes, sir.
You have understood how we got it 7? Total there were how many subjects? 9 subjects. But that 9 has become now 7. Why? Because the 2 subjects are compulsory and that is not for your choice. Right? And that is why we have removed those subjects, because by hook or crook you have to have those subjects. And that's why the total number of choices available is now only 7. Out of these 7, you have to now select any other 3 subjects to make it all together 5. Am I right?
Yes, sir.
And therefore we can have 7C3 and simplify it now. 7 factorial divided by 3 factorial into 7 factorial is equal to 7 factorial 4 divided by, this is the lowest factorial, this can be factorized, right? So this is 3 into 2 into 1 into 4 factorial as it is. Now simplify this is cancelled. 3 3s are 6, 7 5s are 1. We have this many choices to select the remaining 3 subjects. Is it clear?
Yes, sir.
Okay. Question number 10. Question number 10. In this question we have, in a college team there are 15 players, of whom there are 3 teachers. In a college team there are 15 players, of whom 3 are teachers. There is a team in the college. Total number of members in that team is 15. Out of those 15, 3 of them are teachers. In how many ways can a team of 11 players be selected so as to include so and so? Now we have some conditions. We'll see it one by one. But first of all, to do this question, we need to understand that in this college team, total there are 15 members. Right? Out of those 15 members, 3 of them are teachers and the remaining will be obviously students. So, with the number of students we have in that team, and then we have some teachers also, the number of students in total, it is 15. Right? Since there are 3 teachers in that team, obviously the remaining will be the students. And therefore, total how many students do we have? 12. Now from this team, we are going to make a team for which game? The name of the game is not included, not mentioned. So we can say we have to make a team of 11 players. We have to make a team of 11 players. We are going to create a team of 11 players. Is this okay? The condition is only one teacher. Poor teacher. Only one teacher. Okay? So from the teacher group, only one of them can participate. can take part. The remaining will have to be the student. The team has to be of 11 members. If one of them is a teacher, how many will be the student then? 10. And this is how you are going to make the team. So how can we write this in the form of NCR? We will find out the number of ways in which we can select the student, and that will become your 12C10. And then the number of ways we can select the teacher is 3C1. And if you apply the principle of counting, then you will realize that just by finding the number of ways of the student, we are not able to select the team. The work is incomplete. So we have to select the teacher also. Only then the team will be completed. And that is why this case becomes the case of dependency, and therefore we will multiply. Is it very clear?
Yes.
So, number of ways team selected will become equal to 12C10 into 3C1. We can simplify and get the number of ways. Is it clear? This is 12 factorial over 10 factorial into 12 minus 10 factorial into 3 factorial over 1 factorial and then 3 minus 1 factorial. This is equal to 12 factorial divided by 10 factorial into 2 factorial, then it has 2 into 1. This is 3 into 2 factorial. 1 factorial we don't need to mention, no, because it will remain 1 only. This is 2 factorial. Now we can simplify. This is gone. This also cancel this. 2, 6 is 12. 11 is 66. 3 is 198. In total 198 ways we can select the team. Is it clear?
Yes, sir.
Thank you. Now condition is different for selecting the team. In the previous question, only one teacher was allowed to play. Later on, after realizing the talent of the teacher, the students they thought that why not we give a better opportunity to the teacher also. So they said at least one teacher should play. At least one teacher must play. That means now this condition is different. Now you have choice. There has to be at least one member from the teaching faculty, but it can be more. It can be even more. So then what is the total number of ways in which the team can be selected? So the first possibility is maybe we can have one teacher, then in that case we will have total 10 from the student, right? And then if we have 2 teachers, then there can be 9 students. And if all 3 teachers also, because all the 3 teachers can also play, because the condition is at least one has to play. That means more than one also can play. So all the teachers also can play. In that case, we will have the total number of students as 8. So these are the 3 possibilities. These are the 3 conditions under which we can form the team. Not the possibility. These are the 3 conditions under which the team can be selected. So from here we can find out the number of ways. Is this very clear?
Yes.
Now, along the row, if you see, you are able to complete a team if you follow this row. If you follow the instruction along the row, you can have 10 players, 10 from the student faculty and 1 from the teaching faculty. You are able to complete the task.
Yes, sir.
Right?
Yes, sir.
So, either you can have your team in this format, or you can have your team in this format, or you can have your team into this format. I am using the word or. And in the very beginning, I told you what's the meaning of or and in the permutation combination. The meaning for or is what? Can you be audible? Addition. Or stands for plus, and stands for multiplication. So here we will add all the 3 different conditions, and we can get the total number of ways in which the team can be selected. Is it very clear?
Yes, sir.
Total number of ways to select team. This will be 12C10 into 3C1 plus 12C 9 into 3C 2 and plus 12C 8 into 3C 3. We can now simplify 12 factorial over 2. Can I write directly now?
Yes, sir.
2 factorial into 10 factorial. Is this okay?
Yes, sir.
Into just 3. I am just writing the result of this.
Yes, sir.
You can check this calculation in the rough now because we have done so many questions now.
Yes, sir.
Plus 12 factorial over 9 factorial and then 3 factorial. This also will be just 3. This is now 12 factorial over 4 factorial into 8 factorial and this will become 1. 3C3 NCM is always equal to 1. Now we can simplify. This is 12 into 11 into 10 factorial divided by 2 factorial is 2 into 1 into 10 factorial into 3 plus 12 into 11 into 10 into 9 factorial divided by 9 factorial into 3 into 2 into 1 into 3 plus 12 into 11 into 10 into 9 into 8 factorial divided by 4 into 3 into 2 into 1 into 8 factorial. Is it okay now?
Yes, sir.
We can simplify this 10 factorial down. This 2 6 are 12. Then 9 factorial cancels. 3 2s are 6 and 6 2s are 12. Am I right?
Yes, sir.
Then 4 3s are 12 out. Then 2 8 factorial and 2 5s are 10. Clear? Is equal to, from here how much we get now? 6 into 11 into 3. So 6 3s are 18 into 11. Right? Or 66 into 3. It will become 198 plus, here we get 11 into 2 into 10. 22 into 10, 220. Wait. Into 2, into 3 also, no?
Yes, sir.
2 into 11 into 10 into 3. So this becomes 660. This becomes 4 to multiply by 3. It becomes 660. Am I clear now?
Yes, sir.
Then last one is 11 into 5 into 9. Alright? So can you please help me? 55 into 9 comes how much?
495.
495. That's all. And then we can add and then get answer. 8, 5, 13, 3 carry 1, 10, 6, 16 and 9. 25. 5 carry 2, 4 to 6, 4, 10 and 11. And 2, 13. 1, 3, 5, 3 is the answer. Is it very clear?
Yes, sir.
Now we'll take a jump and then we will move on to question number 25. First of all, then we will come back. Again, we will come back. Okay. This talks about the circular permutation. This talks about the circular permutation, or maybe the circular arrangement. Better in place of calling permutation, because I don't know whether it is going to be permutation or it is going to be combination. Right? So we will talk about the circular arrangement. So we will draw a circle. This is the circle. The question says there are 5 gentlemen. Wow. There are 5 gentlemen and 4 ladies to dine on a table. They are going to sit on a table. Okay. Then that is question number 24. Sorry. We'll make this correction because the circle is already drawn. So I cannot go to question 25 now. I'll go to 24. Again, then after that we'll go to 25. Clear?
Yes, sir.
So there are 5 gentlemen and 4 ladies to dine at a round table. In how many ways can they sit themselves so that no 2 ladies are together? See, in most of the question, they are very particular about the ladies, that they should not be together, isn't it? So, we will also know with the situation we appreciate. Now the condition is, no two ladies can sit together,
Yes, sir.
right? In that case, we will first of all fix the position of the gentleman. Is this okay? And you know very well that in the circle, we don't know from where to begin, and that is why we use one of the element, one of the member to fix it as a starting point, right? So first of all, we take one gentleman and then we fix him at this point, and we'll say this is the initial point, this is the starting point, and that's how one of the member, one of the gentlemen is used, and he will not be counted because he cannot be now rearranged. His position is fixed. There are 5 gentlemen, and now they are going to sit. The remaining of them we will put here. So 2, then this is 3, this is maybe 4, and then this is 5. This cross represents the gentlemen. Is it okay? They are seated now. Now, in how many ways they can sit? How many ways? In how many ways this gentleman can sit? For circular arrangement, we always have n minus 1 factorial. Factorial n minus 1. Since we have already used 1, so the number of ways in which this gentleman can be represented, can be seated, is factorial 4. Number of ways for gentlemen to sit will be 5 minus 1 factorial. Is this very clear? But the work is not over. Now we have to make the ladies to sit, right? Let us see how many spaces and in how many ways we can arrange them. How many spaces are available first of all. Make sure that they should not sit together. That means they have to sit alternate, right? So 1, 2, 3, 4, 5. We have space 1 more than the number of ladies. Ladies, there are 4 in number. So they can be arranged in 5C4 ways. The ladies can be arranged in 5C4 ways. So the number of ways, ladies, number of ways ladies can sit. This will become 5C4. And therefore, we can find out the total number of ways in which the ladies and the gents can sit. Is this okay?
Yes.
Now, when we say ladies and gents can sit, these two are interdependent, because you have to make both the groups to be seated. Just by making the gents seated, your work is not over. The ladies also have to be seated, and only then the task will be completed. And therefore, this becomes the case of dependency. We will multiply and get the answer. Is it okay? So the total number of ways will become equal to factorial 4 into 5C4. Do you want me to complete this question?
No.
Thank you. This question number 25 is a very interesting question. Right? This is completely different from all the questions in this exercise. It's very important for us to know question number 25. See the question. There are 12 points in a plane, of which 5 are collinear. I hope you all know the meaning of collinear. Collinear. Collinear means points lying on the same line. Points lying on the same line are called as collinear. There are 12 points in a plane. No, in a plane means you can have a paper. Is this very clear? You can have a paper, and on that paper, anywhere, randomly you can make some 12 points. You can mark some 12 points. Is this very clear? So you have total 12 points, out of which 5 of them are collinear. Now the question is, find the number of triangles that can be formed with the vertices at these points. There are 12 points on the plane.
Yes,
And you have to find out the number of triangles that you can make from this 12 points. Is it okay? Okay. Now you tell me first of all, how many points you need to make a triangle?
3.
Very good. So the number of ways in which we can find out the number of triangle will be 12 C3. The total number of points available is 12. So we'll find out the number of triangles. Number of triangles will be equal to 12 C3. Is it okay?
Yes, sir.
But after doing this, I suddenly realized that this can be possible if all the points are non-collinear. If the points are all non-collinear, then we can have this many number of triangles. But there are some points which are collinear. And if you have points collinear, you cannot frame the triangle. No, just take some few points on the same line and then try to show me the triangle. You will not be able to show me the triangle because the points are collinear. That means those 5 points will not be able to give you any triangle. Isn't it? And by doing so, I have included, by mistake, I have included those triangles also. That means I need to subtract those number of triangles. Am I clear or not? So, since 5 points are collinear, therefore, the actual number of triangles will be 12C3 minus 5C3. Am I clear or not?
Yes.
This will give you the actual number of triangles because those 5 points are not in a position to give you any triangle. So the triangle calculated by those 5 points will have to be eliminated. And that's how we will get the answer. So when you simplify, 12 factorial, 3 factorial, 9 factorial, minus 5 factorial over 2 factorial into 3 factorial. I am writing it directly. I hope you are able to understand now.
Yes, sir.
This is then 12 into 11 into 10 into 9 factorial divided by 3 into 2 into 1 into 9 factorial minus 5 into 4 into 3 factorial. This is 2 into 1 into 3 factorial. This and this will cancel. 2 to the 4. This will cancel. This one, 3 to the 6, 6 to the 12. Am I clear? How many it comes now? 11 to the 22 and 22 into 10, 210. No, 220. 11 to the 22. 22 into 10, 220. This is 220 minus 5 to the 10. So you will have total 210 triangles. Is it very clear?
Yes, sir.
Thank you. The next part of this question of 25 talks about the line that can be made from 12 points. The number of lines that can be obtained by joining the different points. Total there are how many points? Total there are 12 points. So how many lines can be made out of these 12 points? This is the next question. Right? The first question was about the number of triangles. We calculated the number of triangles that can be formed by using 12 different points. Is it very clear? When we talk about the triangle, we knew that how many points are required to create a triangle. 3 points. Likewise, we also have to know how many points are required to draw a line. 2 points. We need 2 points to make a line. Here we have to find out the number of lines that can be drawn by using those 12 points. Is it very clear? So in the beginning, I thought the number of lines that can be drawn, number of lines to be drawn will be equal to 12C2. 12C2. If now this we will get this many number of lines only if the points are all non-collinear. If the points are all non-collinear, then we can have this many number of points. Maybe if one point is here, one point is here, one point is here, one point is here, then we are able to get that many number of lines. Okay? Maybe then we are able to join, and then we are able to get it. This is also line, this also is line, all these are line, right? But if some points are collinear, this is the line, and some points are here. Is it okay or not? How many lines are here? You have used total 5 points. How many lines do you have? Only one. Only one. Otherwise, if these 5 points were non-collinear, then these 5 points could have given us how many number of lines? 5C2. But because these points are all collinear, so they are not able to give us 5C2 number of lines, but they are giving only one. Is this very clear or not?
Yes.
And therefore, when we calculated here, we did not know that the points are collinear also. We just calculated it blindly. But only after calculating this, we realized that there are some few points collinear, and therefore we need to subtract that many number of lines which are on the collinear. Which are collinear. And therefore the actual number of lines will become actual number of lines will become equal to, from 12C2 you will subtract, because 5 of the points are collinear, so the number of points obtained from this is 5C2. So we are eliminating this many number of lines from the total. But while eliminating this many, we did not notice that at least one line can be obtained from those 5 points. That also is eliminated. And that is why we need to add 1 at the end. This we need to understand, that why I am writing this one. Because these 5 points which are collinear will not be able to give you this many number of lines, but altogether it will give you at least 1. And that is why this 1 is added. Am I very clear?
Yes, sir.
And that's how we can calculate and get the answer. So this will be 12 factorial, 2 factorial, 10 factorial, minus 5 factorial over 2 factorial, 3 factorial, plus 1 is equal to 12 into 11 into 10 factorial, divided by 2 into 1 into 10 factorial, minus 5 into 4 into 3 factorial, divided by 2 into 1 into 3 factorial, plus 1. This 3 factorial cancel, this 10 factorial cancel, this is 2, 6 is 12, this 2 is 4. This becomes 66. This is minus 10, and this is plus 1. These two are constant, we can add these two together, right? So 66 plus 1, 67 minus 10 is equal to 57. We can have this many number of lines. Is it understood?
Yes, sir.
Thank you.